All right, change of pace. We can't talk about physiology too much without discussing the endocrine system in some capacity. Now, this is going to start a new series talking about the endocrine system, the glands, and the hormones that are involved. And we're going to start with the two glands that are in our brain, and then we're going to work our way down. So, we're going to start with the pituitary, and it is broken into two parts. Well, not broken into two parts. It consists of two parts, the anterior and posterior pituitary. And before I discuss the hormones that are produced by these glands, I need to talk about what a hormone is. A hormone is a chemical messenger. It serves as a signaling chemical that allows the body to do what it needs to do. Like if you're distressed, hormones such as cortisol goes into your system and it does its thing. But I'm going to get more into that later. But first, we're going to discuss the generality of the anterior and posterior pituitary. And we're going to start with the lettering convention. You know, I'm always about the lettering convention. G-Tage or G-Tage. Now, personally, I think G-Tage sounds cooler because it sounds like an anime term. I'm an anime fan. But if G-Tage sounds better to you, then go for it. All right, the first G stands for growth hormone. Now, the growth hormone is responsible for free fatty acid mobilization and gluconeogenesis, or it helps with gluconeogenesis. I can't spell tonight. And what does gluconeogenesis mean? Let's break that word down. Gluco meaning sugar, neo meaning new, genesis meaning beginning or creation. So it helps with sugar production. And whenever you exercise, the effect it has on growth hormone means that it goes up. Again, this is produced in the anterior pituitary. G-Tage is involved with the anterior pituitary. And then you have the thyroid stimulating hormone. Just going to stop it there. Now, the thyroid stimulating hormone is what the name implies. It stimulates the thyroid that is in your neck, and it helps produces T3 and T4, or at least it stimulates T3 and T4. T3 stands for triiodothyronine, and T4 stands for thyroxine. I'm going to discuss those in a later video. And this hormone, thyroid stimulating hormone, is responsible for your metabolism, how you break down fats and how you break down that fat in order to utilize it in energy, which is something else I'm going to discuss later. And T3 and T4, the main difference between the two is that T4 is an inert or an inactive version of T3. So T4 is eventually going to lose an iodine. If I'm not mistaken, it's going to lose an iodine and then it's going to turn into T3 tri-io, hence the term tri-io, T3. So T3 is the more active version of that that's going to push that metabolism process forward. Then we have adrenocorticotropic hormone. Don't need to write hormone there. Now, this hormone is responsible for releasing cortisol into our system. And it is responsible for in response to stress or things that stress us out. And it is stimulated by, or at least it's produced whenever an injury occurs to us, or if we have a burn or something like that. So that's basically what this does. And then we have gonadotropins. Now, gonadotropins are your sex hormones. And I briefly discussed those in another video. But gonadotropins in males, you have testosterone, and then in women, you have estrogen and progesterone. Running out of room. And testosterone is responsible for sperm production, our seed, or the male seed rather. And then estrogen and progesterone is responsible for all the things you will associate with feminine qualities. And in this instance, estrogen and progesterone is for ovum development, which is egg production, and menstruation cycles and things of that nature. That's how estrogen and progesterone operates, and that's how testosterone operates. Then you have endorphins. And before I go into endorphins, gonadotropins, testosterone and estrogen, the effect of exercise it has on that is insignificant, but it slightly increases, but it's not very significant. And adrenocorticotropic hormone, it varies. Some studies says it's variable, and in one study that I'm gonna link at the bottom of the video says that exercise has an increasing effect on it. I'm gonna link those citations at the bottom of the video. And thyroid stimulating hormone, exercise effect, it goes up. Now endorphins, that's the hormone that decreases our perception of pain and discomfort. And that's basically what it does. It eases your pain, in other words. It gives you that feel-good sensation. And in regards to endorphins, whenever you exercise, those endorphins go up. That's why they say if you are stressed out, exercise is one of the main and basic and main methods to decrease your stress, is to decrease the discomfort, or in another way, it could decrease the discomfort from the stress of your exercise routine. And I apologize, I'm stuttering really badly tonight, but you're getting the message. All right, G-Tage. This is all the anterior pituitary. Now the posterior pituitary. Now this part is going to be a little short. The hormones we're going to talk about here: vasopressin, and anti-diuretic hormones. Now, vasopressin, as I discussed in another video, is more affiliated with males, but not exclusive to males. But it is responsible for attachment, aggression, attention, and it also dual and plays role and helps with the anti-diuretic hormone, which is what the name implies. It helps prevent you from peeing. And that's the simple way to put it. Now, I didn't want to get too deep into all of these hormones on this video because I wanted to give you an overview of all the hormones as it pertains to the anterior and posterior pituitary. Now, there are more hormones that are produced, but again, keep following me on these videos and we will get into that. So, hang 10,